So there is a proof that shows exactly how we find the vertex of a quadratic. You don't have to write any of this down.
At all? We don't even take any notes?
I wasn't finished yet. You do need to write down the formula, but how to get there, the proof, I'm not going to require you to write down. Now, remember that the vertex is the top or bottom of a parabola, just like this. So that's what we're ultimately finding. So just get kind of an image of what that looks like. We're trying to figure out what that point is, and we're only given the equation. Of course, it's easy with the graph like we did last week. You just look and see what's the tallest or lowest point of the U. You do need to write this down. Basically, the goal of this proof is to go from something that looks like this to something that looks like this. Now, again, fortunately, we don't have to do it every time. There's a shortcut. There's a simple formula that you'll have to write down, and I don't know if I'll make you memorize it or not. But anyway, for now, just know that you need to know this formula. So basically what we're going to end up with is a number in front of a set of parentheses. It will be minus something, in this case, we'll call it h, and then it'll be plus something. But again, there's a shortcut. If you're given a quadratic equation, you can figure out what a, h, and k are, which is basically the whole goal of this lesson. Figure out what a, h, and k are. It is going to come from a, b, and c, but it won't be a, b, and c. Nope, it'll be different. Except for a. A will remain a. Whatever this number is will be a. Okay, but h and k have their own formula. Again, I'm not requiring you to know what I'm about to show you, and I'm not requiring you to even write it down, but I will explain it because I think it's very important where things come from. In other words, I'm not just going to give you a formula for h and k. I like to explain why. Just going to do some simple algebra here. We're going to divide both sides by a. Okay. Then once we divide both sides by a, the a's here will cancel. We'll have x squared plus b over ax plus c over a. Again, I can't say this enough. You don't have to write this down. You're not required to know it. If you want to do it for extra credit later, that's fine. I've had students do that in the past. Next, we're going to subtract c minus a from both sides. That will cancel the c minus a on the right side. Next, this is the part that would just be really hard for you guys to know. In fact, I had to look this one up myself. We are going to add 1/4 b over a squared to both sides. You'll see why in a minute. Basically, we're trying to get in that form. Okay, then we're going to combine the two fractions on the left in order to do all the fractions on the left. In order to do that, we have to find a common denominator. So we have to multiply the c over a by 4 over a over 4 over a. That will combine one fraction, b squared minus 4ac over 4a squared. All right, we're almost there, getting there. Next, this is called completing the square. We are going to subtract that from both sides. Remember, in algebra, you can subtract the same thing from both sides, and it balances out, just like a scale. Okay, finally, we're going to multiply by a. Not finally, but we're getting there. And that will cancel the a's on the left. And we'll have this on the right. Then we're going to distribute the a. So it'll be a times this, and then a times this. and we'll get this. Then we'll have two a's right here cancel out, and then we get this. Now we're on to something. Then we're going to distribute that minus into both those terms. In fact, we're going to break this fraction into two different fractions and then distribute the minus. Okay, before we do that, we're going to cancel these a's and these 4's. So we'll just have minus c. Then we can distribute the minus into each of these. All right, almost there. Sorry about this long, complicated proof, but I think it's important. So we'll distribute the minus. We'll have minus b squared over 4a plus c. Then we can flip those. And this is what we want. This is what we're ultimately trying to end up with. So here's where we need to write some stuff down. We basically got it into vertex form. Okay? In other words, if you compare these two, this is where h minus h is. So therefore, h is equal to this. Yes, you absolutely have to write this down. H is equal to negative b over 2a. Our k is just c minus b squared over 4a, based on the algebra we did. And a is just equal to a, because it's the coefficient out front. So guys, when I give you the assignment, instead of having to do this long proof, all you have to do is use these two formulas. Okay? You're going to be given an equation. You're going to label a, b, and c, just like with the quadratic formula. You're going to plug them into that to those two formulas. I'm going to do some examples with you. All right, you do need to write this down. The vertex is h comma k. Okay? So whenever you figure h and k out, your answer is going to be a point. Makes sense because the vertex is the point of the graph that's highest or lowest. In the future, you'll need to know that the axis of symmetry is x equals h. We won't focus so much on that today as we will the vertex, but we've already talked about the fact the axis of symmetry is just the x value of the vertex. Okay, putting all that together, if we want to really simplify it, whenever you're given a quadratic equation in standard form, this will be your vertex. All you have to do is figure out a, b, and c and plug them into that vertex formula. That's it. And again, the axis of symmetry would just be the x value of the vertex, which is negative b over 2a. So let's do an example. I know this all seems complicated, but once you do this example, I promise it's going to be simple. All right, so first example, 3 times f of x equals 9x squared minus 18x plus 3. What is the vertex? Yes, so the first step is to get y or f of x by itself. So we are going to divide everything by 3. In fact, the first step is to get in the standard form. Now, by standard form, your x squared term needs to come first and has to have a number next to it. If nothing's there, you're going to put a 1, because 1 times x squared is x squared. Then the next thing that follows is your x term. Should be a number there, coefficient there. And then after that, you should have a constant number.
So where do these
That's,
letters come in?
hold on a second. That's what it means to be in standard form. You have a number x squared and then another number x and then plus 1 or plus a constant. Let me ask you guys a couple questions. What if it was just like x squared plus 2x? What would the third number be?
1.
No, 0, yes. you'd have to add a plus 0. What if there was no middle term? What if it was just x squared minus 1? 0x, yeah, exactly. You have to have 3 terms there. If there's nothing there, it's basically going to be a 0, okay? Because anything plus 0 is 0. So once you have it in standard form, you can easily figure out a, b, and c. Just like with the quadratic equation, it's the coefficients of the x. So the number in front of x squared is going to be your a, which is 3. The number in front of your x term is your b, in this case negative 6. And your constant at the end is c.
You gotta get really hard.
And now we write.
Yeah. So make sure you have this formula written down somewhere.
I know.
Okay. So this is the formula for Vertex. And we're just plugging in. Remember, when you plug a number in, make sure you put it in parentheses. We're plugging in all those numbers into the formula. So for example, b is negative 6. Okay, so every time there's a b, I'm going to plug it in, make it plug in negative 6. Okay, so for example, with the b, every time there's a b, I'm going to put in a negative 6. There's a b here, I'm going to plug in negative 6. Okay, every time there's an a, plug in 3. So right there, there's an a, I'm going to plug in 3 there. There's an a there, I'm going to plug in 3. Every time there's a c, plug in 1. So there's a c. There's only one c actually in the formula, and that's in the k part of the point, like h comma k.
And then once you have like all the points, do you want to put it in?
Okay, so order of operations, we probably need to multiply, right? Or actually, no, that we have an exponent over here. So we'll have to square that, which is 36. So negative 6 squared is 36. And then we can go ahead and multiply this as well. So that's going to be positive 6 over 6. 6 over 6 is 1. And then 36 over 12 is 3, so we're going to divide before we subtract. And then finally, 1 minus 3 is negative 2. There's our vertex. That means that's the highest or lowest point on the graph. In this case, it'd be the lowest. Based on the original formula, I can tell that's going to be pointing up. 1 minus 3 is negative 2, yep. But you would divide this first. Remember, you divide before you subtract. Okay, let's do another example. We have f of x equals 1/2 squared minus 3x plus 10. Can anybody tell me what a, b, and c is right off the bat? Yep, 1/2 is a, b is negative 3, c is 10. Okay. Most of these I think are already in standard form, at least on the worksheet, so you don't have to divide by 3 like on the first example. So this one is already in standard form. Then we're just going to write out a, b, and c, like you guys said. A is 1/2, b is negative 3, c is 10. Same formula, and we're just going to plug that stuff in like we did before. And again, I'm going to show this just so you guys know. Wherever there's an a, I'm plugging in 1/2. So this time a is a fraction. There's an a here, so I'm going to plug in 1/2 there. Wherever there's a b, I'm plugging in negative 3. And there's only one c right here. I'm plugging in 10 because that's what c is equal to. Then we're going to simplify that. So we're going to multiply the bottom. 2 times 1/2 would be 1. then we're going to square the negative 3, which is 9. So it's going to look like 9 for that exponent, and then 1 on the bottom there. Then we can divide. Negative 3 over 1 is negative 3, and apply that negative, it just comes positive 3. Divide here, that's 4.5, and then just subtract. Yes, your vertex needs to be a decimal, preferably not a fraction, so that's why I did 4.5 there. And then 9 minus 4.5 is 5.5. That's going to be your vertex, 3, 5.5. So again, just to see what that looks like on the graph, and you don't have to graph these, but just for the sake of comprehension, it'd be 3, 1, 2, 3, 4. Somewhere up here would be the vertex, and it's going to be a U shape, so it's going to go up like that. And that's all we're finding. We're finding the bottom of that U. Great question. He asked me, how do I know it's going up? We'll talk about that tomorrow, but for now I can just tell you, if this first number is positive, it's pointing up. If the first number is negative, it'll be pointing down.